Imagine a quiet morning. You're making a hot cup of chai and lighting an agarbati, an incense stick, to start the day. It feels like a simple routine, but right there in your kitchen, you are actually commanding the basic fabric of the universe. Look closely at what's happening. You have the heavy, solid steel pot. You have the flowing liquid water inside it. And you have the drifting, fragrant smoke from the agarbati. What do these three wildly different things actually have in common? The answer is that they are all made of matter. In science, matter is simply anything that takes up space and has weight. The pot, the water, the smoke, and even you are entirely made of matter. Learning how matter works gives us the exact rules for how our physical world is built, and explains why things behave the way they do when we heat them up, cool them down, or mix them together. To truly see how everything is built, we have to look much closer.
We have to zoom in far past what the human eye can see, down to the absolute smallest scale. At this tiny scale, we find atoms. You can think of atoms as the ultimate, unbreakable building blocks of the universe, very much like individual Lego pieces waiting to be snapped together. When these atomic Lego pieces link together, they form molecules. A molecule is the smallest grouping of atoms that actually behaves like a specific substance. This diagram shows exactly that: individual atomic particles clustered tightly together to form the molecular structure of something you might recognize, like chalk. The specific way these invisible molecules group together and how tightly they hold on to each other determines everything we can touch, drink, or breathe. Because molecules group together in different ways, matter generally exists in three main states: solid, liquid, and gas. Which state something is in depends entirely on how closely its molecules are holding hands. This animation shows the molecular structure of a solid. Think of that like a packed train during rush hour. The molecules are jammed closely together, joined strongly, and vibrating in place because they don't have room to move around. Because they are locked in, solids have a definite, rigid shape and volume. Now watch what happens when they loosen up. In a liquid, the crowd is more like a bustling bazaar. The molecules are still touching, but they have enough space to slide and flow past one another. That's why liquids don't have a rigid shape, and instead take the shape of whatever container you pour them into. Finally, if we let go completely, we get a gas. Now the molecules are acting like kids running in a wide-open park. They have wide gaps between them and move rapidly in all directions, bouncing around to fill up every inch of available space. This text from Activity 2 explains exactly what happened with our agarbati earlier. When the incense burned, it released fragrant gas molecules that easily spread through the empty space in the air until they reached your nose. Whether a substance is hard like ice, wet like water, or an invisible vapor, it's made of the exact same molecules. The only difference is the physical dance those molecules are doing. So how do we force matter to change from one state to another?
The answer is sitting right on our kitchen stove. We add or remove heat. This diagram shows how heating forces that change. Look at the first two beakers. When we heat a solid, we give its molecules extra energy. They start vibrating faster and faster until they break their rigid, packed formation and become a looser liquid. We call this process melting. If we keep boiling that liquid, we add even more energy. Notice the third beaker here. The molecules are now moving so fast that they break away from each other completely and float upward as a gas. This is called evaporation. And we can run this entire process in reverse. If you cool a gas down, you take that energy away. The flying molecules slow down, lose their speed, and are forced to huddle back together into a liquid state. This reverse process is called condensation. By simply adding or removing heat, we are acting like traffic controllers, determining the exact speed and spacing of the universe's tiniest building blocks. Let's go back to our morning tea. When you drop a spoonful of solid sugar into hot water and stir, it seems to vanish. But if matter is real, physical stuff, where exactly does the solid go? This text explains the science behind that disappearing act. The solid sugar is called a solute, and the liquid water doing the dissolving is called the solvent. When you mix them, they form what is known as a solid and liquid solution. The sugar doesn't actually disappear. The sugar molecules simply separate from their solid block and find hiding spots in the tiny empty spaces between the loosely packed liquid water molecules. But this doesn't work with everything.
The Activity 4 description below asks what happens if you drop an eraser into water. Even if you stir all day, the eraser won't break apart to fit between the water molecules because it is an insoluble solid. Mixing a solution-lit sweet tea shows us that matter can completely change its visible form, hiding in plain sight, without losing a single atom of its actual substance. There is a big difference between dissolving sugar or melting ice and the match we burn to light our incense. This brings us to the two main types of change that happen in our world. The first is a physical change. This diagram illustrates a perfect example: heating ice into water and boiling water into vapor. No new substance is created here. It's still just water. And if you cool it down, you can reverse the process and get your ice back. The second is a chemical change. Look at this photograph of burning paper. The text points out that burning breaks the original molecules apart and forces them to rearrange into something entirely new, like ash and smoke. This change is permanent, and you cannot easily reverse it. While physical changes simply push molecules closer together or pull them further apart, chemical changes rewrite the very structure of the molecules to create new materials entirely. So, as you take a sip of your morning chai, remember what you're really looking at. From the steam rising off the surface to the heavy cup in your hand, your entire world is a never-ending, invisible dance of molecules. Stay curious and keep watching the dance.